Ignition sequence starts.
Good morning and welcome to Mission Control Houston. You're looking at the International Space Station Flight Control Room, where the specialists monitoring the systems on the station are once again working with a crew of just 6 astronauts and cosmonauts who got Expedition 61 underway early Thursday. ESA astronaut Luca Parmitano of Italy is the new station commander, and he and his crewmates are already preparing for a string of battery replacement spacewalks that are scheduled to begin on Sunday morning.
Welcome to Space to Ground. I'm Catherine Clayton. A few crew members said goodbye. Preparations for a serious spacewalk and plenty of science make for another busy week on the International Space Station. 3 station crew members closed the hatch on their Soyuz spacecraft, undocked from station, and made the trip back to Earth. NASA astronaut Nick Hague, Expedition 60 and Roscosmos cosmonaut Alexei Ovchinin, and United Arab Emirates astronaut Hazza Ali Al-Mansouri ended their time on station Thursday. Hague and Ovchinin completed a 203-day mission that spanned 3,248 orbits of Earth, or 80.8 million miles. This was Hague's second spaceflight and the third for Ovchinin. Al-Mansouri wrapped up an 8-day stay on the station. Their undocking marked the beginning of Expedition 61. European Space Agency astronaut Luca Parmitano will command the Expedition 61 crew, comprised of NASA astronauts Christina Koch, Jessica Meir, and Andrew Morgan, and Russian cosmonauts Alexander Skvortsov and Oleg Skripalka. And things kick into high gear for the crew this Sunday with the first of 5 complex spacewalks scheduled in October. The spacewalkers will continue the ongoing work to upgrade the large external batteries on the station, swapping older nickel-hydrogen batteries with new lithium-ion batteries recently delivered on the Japanese HTV-8. The upcoming battery swaps will be unique from previous spacewalks, which use extensive robotics to do the heavy lifting. The batteries set to be replaced starting on Sunday are located on the far end of the station's backbone, also called the truss, and are out of range for the Canadarm2. This means the astronauts will have to carry the 400-plus-pound battery packs back and forth by hand. Sunday's spacewalk is expected to last over 6 hours, with coverage on NASA TV starting at 6:30 a.m. Eastern. Amidst the departures and the spacewalk preparations, astronaut Christina Koch still had time for science. She kept the biomolecule extraction and sequencing technology, or BEST investigation, on task with sample transfers and culture media exchanges. DNA sequencing allows researchers to explore the molecular world. The BEST investigation seeks to advance sequencing in space in 3 ways: identifying microbes that cannot be detected using traditional methods, assessing microbial mutations in the genome because of spaceflight, and performing direct RNA sequencing. Sequencing in space allows for real-time snapshot of gene expression, which will help protect humans during future space exploration missions and help monitor the presence of microbes in remote locations on Earth. Keep sending in your questions using the hashtag AskNASA, and we'll see you next week.
We'll have more details on the 5 battery replacement spacewalks in an EVA briefing this afternoon at 1 p.m. Central Time on NASA TV and online at nasa.gov. Our live coverage of the first of this set of spacewalks goes on the air at 5:30 Houston time this Sunday morning. Then the second spacewalk is targeted for next Friday, October 11th. And one more schedule note. This afternoon at 3 o'clock Houston time, tune in for a video file of scenes from astronaut Nick Hague's return to Houston earlier today. There is a long list of tasks that need to be completed to get a space station crew ready for a spacewalk. Well, the fact is, those preparations actually begin before the crew members even launch to space. In this demonstration video, astronaut Ricky Arnold shares some of the training astronauts get on the ground to be ready to walk in space.
Welcome to the Quest airlock on the International Space Station. I'm Ricky Arnold, Expedition 56 flight engineer from NASA. Today we're going to talk about one of my favorite topics, extravehicular activity, or EVA. Going out on an EVA or a spacewalk has been one of the most amazing experiences of my life. But it's also one of the most complicated and dangerous things we do during human spaceflight. There's a lot of equipment to prepare and maintain, and we do months of training to make each EVA a success. If you think it sounds complicated, you should see all of it in action. Let's start with training and how we get ready for a spacewalk.
Space is an extreme environment that presents many hazards. If we're going to go outside the safety of the ISS, we have to be prepared. That's why EVAs are designed with safety as the utmost priority. We astronauts spend a lot of time in the classroom, just like you are now, learning about the hardware we'll be using and the specific parts of the space station we'll be working on. Then we get to go spend a lot of time training in NASA's giant pool, called the Neutral Buoyancy Lab, or NBL. Since it's impossible to simulate microgravity on Earth, the next best option is water. 6.2 million gallons of it. The NBL is 40 feet deep, 202 feet in length, and 102 feet in width. A lot of room to have a full-scale working model of the ISS, which we need for practicing our EVA maneuvers and assigned tasks. We get suited up and weighted so that we're neutrally buoyant in the water, so we don't sink to the bottom and we don't float to the surface. It's a great way to simulate the microgravity we'll be experiencing. We do several dress rehearsals of the EVA before we launch. This gives us the opportunity to prepare for any anomalies that may occur. We spend at least 5 hours practicing in the NBL for every 1 hour planned for the spacewalk. So we are very well prepared to execute the EVAs once we are in orbit. Once we are up in orbit, the EVA preparation continues. First, we must perform a pre-breathe protocol to displace the nitrogen in our tissues and help prevent a condition called decompression sickness. During pre-breathe, we breathe 100% pure oxygen and do some light exercise to help purge the nitrogen from our bodies. During pre-breathe, we will also don our extravehicular mobility unit, or EMU. This is a fancy name for a spacesuit. The spacesuit is basically its own spacecraft, shaped like a human. There is usually a red stripe on the leg of one astronaut, but not the other, so the ground can tell who is who. To ensure our safety at all times, we are always aware of our safety tethers and where we are in relation to our spacewalking buddy.
Hey, buddy.
There's a fellow crew member called the IB, the intervehicular crew, on the inside of the airlock, watching and communicating with us as the EVA progresses. We are also prepared for several contingencies should they occur. First, we are trained on the use of a jetpack that can be used to maneuver in the event of an emergency rescue. It's called a SAFER, or Simplified Aid for EVA Rescue.
The view during an EVA is magnificent. It's beautiful out there. It's also extremely dangerous, but our months of preparation and all of those dedicated people working on the ground, working around the clock, ensure we are safe as possible when we work outside the ISS. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
There was another bit of milestone news on orbit this week. Flight engineer Christina Cook completed 200 days in space on a mission that's scheduled to last until next February, almost 330 days total. She says the concentration and control she learned in mountain climbing helped her prepare to be an astronaut and to make the climb to space for her first mission to the International Space Station.
I first got involved in rock climbing actually in college. My college, North Carolina State University, offered rock climbing as a PE class. So it sounded really exciting, maybe a way to kind of get outside and have a little adventure. When I first got started, I liked more the physical challenge. That's what it was about. And as I kind of advanced in the hobby and got more technical, I found that I really liked other aspects of it, like the equipment, the gear, the physics of the system that you have to use, and also the partnership aspect of it. It's really like a team, because when you get into some of the higher levels of climbing and different types of more technical climbing, you really rely on your climbing partner. We train for spacewalks in a giant pool that's called the NBL, which stands for Neutral Buoyancy Lab. And it's a pool that's large enough to fit a full-scale mock-up of the International Space Station. So in that, we simulate everything like we would on a real EVA, including egressing out of the airlock, your safety tethers, and your local tethers that you would work when you're at a work site performing the job. So all of that is just very similar to the concepts of rock climbing. So during my astronaut interview, the most memorable question that I had from the interview committee came from Peggy Whitson, who, as you know, is a famous astronaut for having the longest time in space. She's done many, many spacewalks. She's a hero of mine. And she looked at me and she said, "When you rock climb, have you ever been scared?" And I felt like she was seeing right to my soul when she asked that question. And I feel like the answer to that question was absolutely, I have been scared. And that's when I really kind of found the fact that turning that fear that you might be having into focus is so important. And I think that's what she was drawing on when she asked that question. So that was a pretty profound moment in my selection process. I'm Christina Cook, and I'm an astronaut.
One priority of the International Space Station's science mission is to learn as much as possible about how living in microgravity impacts the human body. Well, shortly before she came home in June, flight engineer Anne McLean and her crewmates completed the data gathering on the airway monitoring experiment. It examines an astronaut's exhaled breath for signs of inflammation. That data is rolled into the design of future spaceships to make them safer for their human crew members.
The International Space Station is a national orbiting laboratory. Every single day we are answering big questions about Earth and about space, about where we came from and about where we're going. One category of those experiments are human research, experiments on our human body, how we react in microgravity. One of the recent ones that I've been a part of is called airway monitoring, and this is looking at airway inflammation up in space. So when we're breathing the air, you know, the small particles in the air, they don't just fall to the ground like dust on the ground. So we tend to inhale more fine particles than we would on Earth. And so we're looking at our response, our body's response to that by measuring nitric oxide exhalations as an indicator for airway inflammation. And so understanding, you know, how clean does our air need to be? How does our body react to the air? When we talk about going back to the moon, you know, a lot of people are aware that the moon dust is a very, very fine particle. It's almost like a powdered sugar fine particle. And if that's in the air and we're breathing that for months on end, if we're doing, you know, extended stays on the lunar surface, you know, we need to understand kind of how that affects the human body.
Another one of the hazards confronting future crews who will explore beyond low Earth orbit is the radiation that those men and women will encounter on the long trip. NASA's Human Research Program has been looking into several ways to try to shield astronauts from galactic cosmic radiation.
Just as early explorers had to endure weather as they traveled to new lands and explored new areas, astronauts, when they go on space travel outside the Earth's magnetic field, will have to endure space weather. This space weather would include things like galactic cosmic rays, which are remnants from supernova, and also solar storms, which include things like solar particle events and coronal mass ejections. So as astronauts are traveling to Mars, they're going to be enduring the space weather, and it's harmful to the body in a couple different ways. There's an in-flight risk from things like solar storms, and those really present acute radiation sickness type issues that would have to be dealt with operationally in real time. And then there's also long-term late effects like cancer, cardiovascular disease, and possible central nervous system effects. And those are more possibly late-term effects that would come into play after the mission. So just like the early explorers, NASA's mission is to bring all of the astronauts home safely. And to do that, we're investing and looking into these shield design strategies that include ways that mitigate exposure from all forms of space weather. So we look at habitat design and overall vehicle optimization to reduce the in-flight risk from solar storms. But then we're also looking at material design and other vehicle optimization strategies to reduce the risk from long-term exposure to galactic cosmic rays.
People in the Human Research Program are one example of the kind of heroes who work at NASA. Along with the astronauts who fly to space, there are many thousands of other people hard at work solving the challenges facing the space missions of today and those of tomorrow.
So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website.
Missions like going back to the Moon by 2024 and then out into the solar system to Mars face issues with providing the human crews with all the materials they'll need to do their jobs. Biomining could offer a way for crews to obtain needed materials right on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do here, and that might affect the output from extraterrestrial biomining. So there's an investigation on the International Space Station studying how microbes grow and how they alter planetary rocks in microgravity and in simulated Martian gravity.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
The range of science research being done on the International Space Station is remarkable, and the station program's science office is hoping you can help expand that range. If you've got a hypothesis to test that requires eliminating gravity as a variable, have we got a research platform for you?
Hi, I'm NASA astronaut Megan MacArthur. Did you know there's a research laboratory in space? It's the International Space Station, and it's a scientific stepping stone that's enabling us to explore farther into space while improving life on Earth. The space station provides a unique environment of microgravity, extreme conditions, and an observation platform that enables researchers from all over the world to test theories and technologies off the Earth in an extreme environment unlike any other. We welcome you to join us on station. You don't have to be a rocket scientist or part of NASA to gain access to this unique laboratory. Don't know much about spaceflight? That's okay. We're here to help people just like you every day. You might be curious about funding, capabilities, access, or maybe you just don't know where to start. Give us a call or email. We'll ask you some basic questions about your objectives, which will help us point you to the right people who could make your experiment or testing your technology possible in space. Visit nasa.gov/station opportunities for more detailed ideas, answers, and contact information, or find us at the Station Research Client Helpline. So welcome to the International Space Station. You'll soon be part of a worldwide group of researchers making discoveries on this amazing orbiting vehicle, all for the benefit of our planet and future exploration beyond.
The laboratories on the International Space Station are designed to facilitate scientific research that can't be done on Earth. Well, the fact that the vehicle orbits 250 miles above the Earth also makes it a terrific location for experiments that need to make scientific observations of the Earth over an extended time period. The RapidScat wind measurement system has been doing that for almost 5 years now.
A new angle on global wind measurements, presented by Science at NASA. Summer can bring with it a whirlwind of activity. Hurricane season causes potential havoc on land with threats of forceful winds and torrential rainfall. A helpful set of eyes mounted on the International Space Station allows scientists to observe these massive storms from a special angle, 51.6 degrees to be exact. That is the inclination of the space station's orbit around Earth. NASA's ISS Rapid Scatterometer, or ISS RapidScat, was launched and fixed to the space station in September 2014, giving it a view of the planet below that differs from any other wind measuring instrument. Brian Stiles, ISS RapidScat Science Processing Lead at NASA's Jet Propulsion Laboratory, says, because of its inclination, RapidScat observes storms in higher latitudes much more frequently than polar orbiting scatterometers. The same location can be observed several times per day, and this lets us see how storms are developing in more detail. The data that RapidScat provides is being used by NOAA to support marine weather forecasts and warnings, providing better observations of storms as they intensify and weaken. Zorana Jelinek, RapidScat project scientist at NOAA, says, RapidScat observations greatly aid in our ability to study temporal changes of wind fields. When observations are available, we have the ability to study changes within 1 hour at high latitudes. Previously, we were only able to characterize changes every 6 hours. In the tropics, RapidScat has improved the wind coverage of the space-borne scatterometer constellation from once every other day to more than once a day on average. ISS RapidScat is a radar, bouncing microwaves off the ocean surface and measuring the echo. Rough waters, those disturbed more by wind, return a stronger signal than smooth waters. From that information, scientists can derive wind speed as well as its direction based on the orientation of the waves. RapidScat excels at measuring winds at the ocean surface, adds Stiles. Measurements of surface winds are important for many reasons. For one thing, surface winds define how the ocean and the atmosphere interact where they meet, which influences weather in the short and long time scales. Moreover, surface winds are what boats experience at sea, and people and buildings actually experience when a storm makes landfall. RapidScat provides remotely sensed ocean surface wind speeds and directions. With such a huge void of radar and surface observations over the oceans, remotely sensed ocean surface winds play an instrumental role in marine decision-making, forecasting, and modeling. Stiles says this is useful information for both weather forecasting and climate studies. Since it was launched, ISS RapidScat has seen dozens of storms, big and small. Maps of surface winds have given Earth scientists a unique view of the inner workings of these storms. The orbit of the space station covers the majority of the oceans from southern Canada all the way to the southern tip of South America every 48 hours. This means few storms escape RapidScat's relentless microwave scanning. These advantages are enticing weather forecasters and climatologists to make increasing use of the high-resolution wind data that ISS RapidScat offers. The information from these data are being utilized by marine forecasters at NOAA to help forecast, warn, and analyze wind and wave conditions over the ocean environment, from hurricanes and windstorms to fair weather conditions. Improved knowledge of impending wind and wave conditions impacts everything from large cargo ship routing to recreational boating to families vacationing along the coasts. As summer unfolds, ISS RapidScat will have a lot to do. For more from the International Space Station, go to www.nasa.gov/station. Stay tuned for updates from science.nasa.gov.
From 250 miles up, cameras and crew members on the International Space Station have a great view of Earth. But it works in reverse, too. There are times when almost everybody on this planet has a chance to see humanity's home on orbit from right in your own backyard. Flight engineer Nick Hague shares how you can use the Spot the Station website at nasa.gov to find out when the International Space Station may be visible to you.
Did you know that we're traveling at 5 miles a second? We're going around the Earth so fast that we orbit it every 90 minutes. That means on the space station we see 16 sunrises and sunsets each day. Every one is magical to watch. But more important than the view, we depend on the sun's light to power our space station. And we use massive solar arrays to soak it up. Those arrays are so large that when the sun's light glints off them, it's possible to see us from the ground. That means you can look up in the sky at dawn or dusk and see our spaceship flying overhead. So take a few minutes to step outside, spot the station, wave hello to us, and remember what we represent. People from across the globe committed to working together to improve life for everyone on Earth.
If you'd like to get another look at any of these stories we ran for you today, check us out on YouTube and Facebook at those addresses. And look around, because you're going to find a lot of other cool stuff about NASA and America's human spaceflight program. Since you're out on the internet anyway, check out Houston We Have a Podcast. We talk to folks about their work in all aspects of space exploration. New episodes post every Friday. Today, Gary Jordan does his history in a talk with the authors of a book about the development of NASA's plans for space exploration in the 21st century and how that activity helped shape the space agency of today. Go to nasa.gov/podcasts for today's episode. It's where you'll also find all of our previous episodes and the full library of all the NASA podcasts. And all of them are also available on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.